These glasses are not safe for observing the sun with, so please don't look up at the sun. But please look at these two lights. Count how many lights you can see here. And when you look at these, because these glasses include a spectral grating, you should see a bunch of rainbows. But when you look at the source of the two lights, you should be able to tell also that they are two different colors. There's some interesting physics going on here that pertains to making sure that the light that we create doesn't pollute the night sky. The light on my left, on your right, is a daylight branded General Electric LED light bulb. And it has a specific temperature that it shines at. It's a bit of a challenge to explain, but the hotter that a light is, the bluer it also appears. When you use the taps on your bathtub, usually the blue side means cold and the red side means hot. But this is a little bit misleading. If you have a gas range in your kitchen and you turn the oven on so that the flame is nice and red, that means that the flame is pretty hot. But if you get it down to a blue flame, that means that it's very hot and suitable for cooking with. Well, in actual physics, the bluer a light appears, the hotter it is. This LED light on my left on your right is bluer than the one on my right on your left. And these two lights have different uses. If it's wintertime and you have seasonal depression, or you're worried about making sure that you have enough vitamin D and enough sunlight, you should probably use lights like the one on my left that give you a nice hot spectrum. This light is giving you a color temperature on the box of about 5,000 Kelvin. The one on my right on your left is about 3,700 Kelvin. This is the kind of light that you should probably use in your house when you're getting ready for bed. This is a light that will not disrupt your biological clock in the same way that the one on your right does. The light that's on your right will simulate real sunlight, and it might throw off your biological clock. And there are some studies that indicate that this is not good for your health. Also, you should probably not use lights like the one on your right at night outside, because it'll fool all of the insects and all the plants into thinking that it's daytime as well. Also, the brighter that a blue light is, the more light pollution it creates due to particulates and wavelengths in the air. So I think you should probably try to choose lights that are using a different color temperature, like the one on your left here, the dimmer, yellower one. It'll still give you good color rendition, and you can tell that because of these glasses. When you look at the rainbow spectrum, you can see that there are different colors being broadcast by that light, and it gives you good reproduction of colors, just like the bright daylight sky. All right, I'm going to replace one of these lights. Okay, so this new light that I've just installed is a compact fluorescent light bulb. These were really popular for a little while, but they're becoming less popular now. I wanted to use this light bulb because it demonstrates something different is going on. The excitation of gases inside the compact fluorescent light bulb is causing those gases to fluoresce at specific wavelengths. And so whereas when you're looking at the spectrum that's produced by the LED light bulb, that's producing a wide range of colors in a continuous spectrum, the CFL light bulb is producing several discrete colors, one red, one yellow, one green, and one blue. So this is not quite the same physical process that's going on that creates those different colors. All right, now that we've all seen these light bulbs, I'm just going to put a cover on them. All right, I've taken the glasses off. Obviously the light bulbs are still shining, but now they are under lampshades. And now I want to talk a little bit more about the legal definition of light pollution. I've got here a copy of the Town of Richmond Hill's Light Pollution Control Bylaw. This is the first bylaw in Canada whose purpose is the control of light pollution. The reason why we have this bylaw here is for the protection of the David Dunlap Observatory. Now, there's a certain amount of legalese in the document, but the broad strokes of this are that with exceptions, lights that are set up outside should be broadcasting no more than 2% of their light over the horizontal. Also, there are certain restrictions on the spectrum of light that's being used, partly because of different kinds of light bulbs being more suitable for use at night, also because certain colors of spectrum from these light bulbs can interfere with observations being done at the observatory. And this document is now more than 20 years old, so some of the technology's changed. This document doesn't say anything about LED lights because 20 years ago, LED lights were not being used in consumer electronics or for your lighting your home. I'm not sure if it's time to update the bylaw. We know that that's somewhat of a fraught process, but we're glad that we have the bylaw nonetheless. So I want to make sure that you're aware when you go home that if you have any lights outside of your house that are shining some of their light up into the sky like this, or so that you can see the naked filament of the light bulb, or if those lights are broadcasting some of their wavelengths into the air at wavelengths that are necessary for the use of the observatory, you should expect a visit from your local bylaw enforcement officer, and you might get a fine. So please be friendly to the David Dunlap Observatory and don't use light bulbs that are against the town's light pollution control bylaw. Thank you.